Yeah.
Okay, I'll drop off now. I mean, I will
Okay.
leave
Thank you,
I will
Shane.
leave the recording on. Yeah.
Thank you. So in terms of architecture, we're kind of okay. So here's what concerns me about the architecture we have today. I feel like we haven't. How do I put this? I feel like the way the user experience is set up today is kind of still weird. So for instance, we don't really enable self-service, even though we say we do. We don't really do it because we still need an admin to come in the way and create a bucket class for a bucket to be created.
Well, that doesn't mean it's not self-service. It just means that there's an installation step in addition to installing the cozy driver. You got to create a bucket class. Once you it's a one-time operation. It's not a per bucket operation. Like
Okay,
if the admin had to do something on a per bucket basis, then you could say, yeah, this is not self-service, but it's a one-time thing they have to do up front. And then from then on, you can create thousands of buckets self-service.
Okay, so did we decide then? So there's a protocol field in the bucket class. Did we decide to move it to the bucket request? I think we did, right?
Yes. We were saying that protocol is tantamount to the volume mode, and the volume, because if you get something other than what you asked for, it's useless to you, and therefore it should be on the BR. And then furthermore, if it is on the BR, it shouldn't also be on the bucket class, because that just creates an opportunity for conflicting sources of truth.
Absolutely.
For no benefit.
Right. Yeah, it should be taken out of the bucket class. What about bucket deletion policy? Would that
that is the kind of thing that, at least for volumes and snapshots, I think it is on the class. And so with the clustered, or the cluster scoped object does inherit it from the class, and that enables the admin to set. I mean, I think you could leave it out, and then you just get the default of true for the deletion policy, or delete for the deletion policy, which means that by default, if you don't do anything, buckets that are created and then deleted actually get deleted. But we can.
Okay, so it has a default. Okay.
I mean, it should. I mean.
Yeah, of course. Yeah, I mean, we had set it as retain, but we already had a default. It was set to retain, but it makes sense to make it delete, actually.
Well, yeah, I mean, different people have different levels of paranoia around deletion. My stance is that delete means delete.
Right.
But
right.
But we had also contemplated. We had contemplated other flavors of deletion policy in addition to just delete and retain, like a delete after last user kind of a thing.
Yeah, the usual delete is delete after last user. We have a force delete, which is like deleted from underneath.
Okay.
But I mean, maybe we should rename that. What?
I don't have strong feelings about those, but I do worry about adding complexity where it might not be to much benefit. I mean, Kubernetes has gotten away with just a very simple delete policy for volumes and snapshots so far, and no one has come yelling at us saying like, "Oh my gosh, I deleted my volume and it's all your fault." It's like,
well,
no,
if someone so if I mean, if someone wants to have more complex policies, they can implement it a layer above.
Yeah, I mean, that's my inclination. Is like, let's make our layer simple, and if people want to do complex things, yes, they can apply finalizers and other controllers with other behaviors, and they can layer in the complexity that they want. But at the bottom layer, delete means delete, because anything else doesn't make any sense. But with the exception of, an admin specified policy to retain things for the brownfield case, like that's the one situation where I feel like, you need a way of saying like, look, this bucket that I'm putting into Kubernetes represents somebody else's bucket that we don't own, but we need to put it into the system so that we can use it. And therefore, when we're done with it, we're just going to delete our representation, not the actual bucket. Right? That's a kind of decision that you make at creation time when you're basically importing a brownfield bucket, is to say that this object represents something that we don't own, and therefore we're not responsible for deleting.
Right. So another question then, when we talk about brownfield use cases,
Sid, where'd you go?
like static, I'm not a big fan.
Yeah, the audio is cutting out.
Yeah, I can hear you cutting out as well. I don't think he hears us. No.
Oh, okay.
Hello?
Sid,
Yeah.
we're losing your
Okay,
audio.
give me 1 second. I'm gonna drive outside this time. Just continue talking. It'll be fine in a second.
I wanted to
but
test something actually. Then.
Okay, go ahead.
I'm just using the time. So I see that in the storage class, there is reclaim policy, right? It's in the class.
Yeah. Yeah.
And is it also on the PVC then?
No,
Like,
no,
can
it gets stamped on the PVs. The PVs have reclaim policies that
But
get
I
copied
cannot
from the storage class.
request. When I make a request, I cannot request this or that, right?
Well, you can specify the storage class. So if the admin has created a storage class with a retain, with the reclaim policy of retain.
No, that I surely understand. But the like we were there saying that if I reference a storage class, it's not portable. So this is why the protocol, for example, we're saying it should express my expectation more than.
Yeah, I mean, so it's tricky when we talk about portable versus non-portable, because the thing that is portable is taking the default storage class, right? If I create a PVC and I don't specify any storage class,
yeah,
there's certain assumptions that are still valid for any storage class, and as long as I adhere to only those assumptions, like my PVC should be portable to any cluster. It's when you get into the special stuff where maybe I'm depending on some subtle aspect of the storage class and I'm specifying a specific storage class that you start to lose portability for that workload. And so there's this balance between having a default that works everywhere and thus is portable versus giving people enough nerd knobs that they can go in and dial in their storage objects just the way they want on their specific cluster with their specific classes. But then those kinds of things simply can't be portable because
it's a name, right? Basically, I just specify a name, and this name can mean anything. It might not be what I meant at all, right?
Right. So unless you have some way of, like, let's say you have a templatized application that you can install on multiple clusters, unless you have some way of going and looking at the list of storage classes on a specific cluster and understanding the difference between them, picking one, and then applying that to your template, then it doesn't really do any good. So
Yep.
as long as you take the default, you should be okay.
So I have a question here. Can you hear me, first of all?
Yes, Sid, welcome back.
Oh, thank you. So about the storage classes, is it fair to say storage classes are only supposed to have, information that apply to a broad set of volumes, that are not just a broad set, more than one volume?
Yeah.
So I'm coming from this. Okay, so I'm saying only fields.
It's a template, right?
Yeah, it's a template, right?
Well, I think of it as like as a menu. You go into the restaurant and you can look. They got the hot dogs and the hamburgers and the cheesesteak, and you pick something, and you're gonna make a lot of hamburgers in any given restaurant, right? Some menu items might get chosen more often, and some might not.
Okay, so you know what? The question is, what can I tweak in the request for hamburger? Because I'm trying to tweak the request, which is general to all of these, right?
Right.
Mm-hmm.
In some way. And I'm trying to say, well, add cheese, but it doesn't make sense in the ice cream, right?
Right. Yes.
So that's where it kind of the decision on putting something in the request makes it complex for the classes in some way.
Right.
And this is why
so-
we don't
so-
have much in the request. Like the request is very thin.
Right, but the protocol is something that it is built into the workload. Like if your workload is expecting a GCS bucket and you give it anything other than a GCS bucket, it's not going to work.
No,
So-
that's perfectly fine, right?
So it's the kind of thing
I
that
agree.
it's the kind of thing that should go into the bucket request, but just like volume mode goes into the PVC, because if you need a raw block volume, a file system is going to do you no good. So
But what doesn't? I mean, what is the rule? Like, what is our thumb rule, right, for saying this doesn't belong to, sorry, to the request object? What shouldn't go there? Like, what is doesn't delete policy go there? Reclaim policy.
But deletion policy, yeah, same thing.
Yeah, deletion and reclaim is the same thing. It's just an unfortunate historical name with the
Yeah.
let me think about how to express this. I guess the way I think about it with deletion policy in particular is that you need to be able, when you create like a brownfield type of volume, if you have a pre-existing volume and you just want it to be available in Kubernetes, you create the PV directly. And then there never is a storage class, right? Because your storage class is only used by PVCs. If you just create a PV that represents a volume that already exists, the system still needs to know what should happen when I delete this, even though there was never a storage class associated with it.
Right.
And so it goes on the object. And then I guess if you had
But it
allowed
goes to
it to
the
go on.
PV as well, right? I mean, the PV gets it as well.
Well, only the PV. The PVC doesn't get it. So that's the.
Oh yeah.
That's the. I guess I'm trying to think of how this makes any sense. I guess you could have put a deletion policy on the PVC that would then tell the system like what kind of PV to create. But like, I guess it just feels like a weird thing to do, right? Because any PVC you create inside Kubernetes, presumably you want to be able to delete it too. Like it would be weird to create a PVC that when deleted will leave garbage behind, right?
Right.
So to be able to set the deletion policy at the PVC layer is a strange thing. Now to put it on the storage class is also a strange thing, to be fair. Maybe the idea there is the admin wants to have a special kind of volume that just never gets deleted. So it's like a garbage generating storage class. So every PVC of that storage class will become garbage upon deletion and just hang around. And I can't think of a good reason to do that, but I think that's how it would work today. If you had a storage class with a reclaim policy of retain and a bunch of users going around creating those PVCs and deleting those PVCs, you're just going to get garbage piling up, and someone's going to go have to deal with it later. But I don't know why you would want to do that. The main reason that I see for having
well, maybe you have a different mechanism for garbage collection of that. I mean, maybe that admin is saying, well, I want to, look at my volumes after whatever 30 days and only then. Whatever.
Perhaps, yeah. But the real value I see with these reclaim and delete policies is the brownfield case, where I want to be able to represent in the Kubernetes cluster a pointer to an object that isn't mine, and therefore it's important that I don't try to delete it. And that's the main value I see with reclaiming. But your higher level question of how do you judge what should be on the storage class versus what should be on the PVC or bucket class and bucket request, it's going to come down to things that only the admin would know about, things that are going to be opaque to the driver, or the things that are going to be opaque to Kubernetes because only the driver understands them. Those things go on the classes because they would have to, because the end user won't know about them. So you put them on the class so they can get passed through as opaque parameters to the driver and do whatever they need to do. Things that the end user would be expected to understand and care about should go on the request object. Or
I think deletion policy falls under the second category.
I mean, I
yeah,
think so
but
too. I
as,
mean,
as we
it
were
might-
so as I was just saying, like deletion policy feels like a special case, where it actually represents sort of a complex contract between the end user and the admin. You know, where you're saying, look, I need to use something, and Kubernetes needs to have a reference to it, but Kubernetes shouldn't delete it. And so I'm going to create this representation object in Kubernetes that only could have been created by an administrator or someone with elevated privileges, right? There's no way to create a brownfield bucket directly without some elevated privilege or some knowledge of the underlying system.
So hold on a second. So you're saying in case of buckets that we create through Cozy, deletion policy is always delete.
By default, I mean, we could follow the you know, what they've done in volumes and allow you to set a different default in your bucket class, and then we could stamp that on all the buckets that get generated by that bucket class, so that you could have some other default deletion policy. But I can't think of a good reason to do that. It's just something that's technically possible.
It's just as the creator of the bucket, you know, I stand to have the most amount of knowledge about whether I can get rid of the data or not, and if I have to rely on an admin
But remember, a bucket created through Cozy, the way it gets deleted is by deleting it through Cozy. So yes, as the end user, you may have knowledge about what its life cycle should be, but the way you control its life cycle is by whether you delete it or not. Like the whole point of the deletion policy is it goes underneath that and it says, look, even when the end user deletes his thing, still don't delete it. It's like a veto point on deletion.
So
Right.
the other use case of that with PVs is the rebind to another namespace, right?
Hmm. Well, not another
That's-
namespace, another PVC.
Well, it is
yeah, not
possible
PVC, but
to,
it can be another
Yeah.
namespace as well.
And yeah.
but you can
Right.
also just directly rebind to PV without mucking with its retention policy.
No,
You can
but
simply have another PV and just rebind it. I mean, have another PVC and directly rebind the PV.
No,
what do you
he
mean?
means like, let's say the PVC is gone and you don't want the PV to go away.
Right.
Yeah, so you put the deletion policy or retain policy to retain, and so the PV remains and it'll be in unbound state, so another PVC can bind to it.
It's like a
So
handover
you
case,
get
I
a-
think,
yeah.
right?
Yeah.
Well,
Temporary, usually.
but that requires some administrator shenanigans to go on
Yeah.
to enable all that, because
yeah.
if
That was
all
the
you
primary
do,
mechanism at one point. That was the only mechanism at one point.
yeah, but
Like-
this is going back to the pre-dynamic provisioner days. Like with the dynamic
Yeah.
provisioner, if you play this game of setting the retention policy to retain and then you delete your PVC and then the PV hangs out, you will never get
cannot
another
bind it,
PVC
right?
to bind to that one.
Right. You have to manually update the PV to reference the one that you want to bind, right? Is that kind of
No,
what
you would
need
have to
do?
create a new PVC and specify the PV name as part of your PVC spec.
And then go and update the PV also.
No,
Do you also
the
need
point-
to update the PV?
the bind controller will handle that case. If you have an unbound PV
Okay.
and you create a new PVC and you specify the PV name in the spec, it will bind. But like that's a weird thing to do.
Hmm.
No, but isn't that the handover case when I want to like move the PV to another PVC, right? Basically, how do I do that? Otherwise, can I do it? Because I know that
Well,
a lot of use cases rely on that to do some migrations and change between these or that YAMLs, stateful sets, etc. Sorry. Yeah.
Yeah, it depends on having the delete or the retention policy set correctly, and an ordinary user isn't going to know that is the case, right? Because you can't see the PV. An ordinary user
That's
has
true.
to presume that when they delete their PVC, it's probably going to just go away.
It needs admin's help for that, right?
Yeah.
For
So there's a presumption that the admin is playing some game if you're mucking with these policies and doing things. And the thing that I don't fully have my mind wrapped around with Cozy is for our brownfield bucket use case, like, can we get out of the world where like an admin has to be involved. Because as I understand it right now, our plan is the way you do brownfield is you just have someone with admin level powers directly create a bucket, set the deletion policy to retain, and then start creating BARs that point to it, which it's workable, but it does involve an admin at that first step. And so I haven't yet heard the plan where someone other than an admin can take a bucket from outside the system and pull it into the system.
Well, it doesn't sound too complex for a driver to do, right? So I would imagine the drivers would probably allow it in some, through their API, perhaps.
Wait, hold on. What do you mean by driver?
Yeah. What does a driver need to do?
If you want, no, maybe it will be easier, like for, let's say, AWS S3, right? So if I would like to import a bucket, basically, to my Kubernetes cluster from AWS, then one way is to have an administrator create that YAML, but another way is just to have the driver generate that bucket, because it knows how to create buckets anyway for the greenfield case and all that.
How does the request get to the driver? Like, what is the?
So I'm saying that it might be out of the scope of Cozy, and just in whatever API that the driver has for its not client in the sense, but like it will be the user of it will be the driver's user, I guess, right?
I mean,
so if I deploy MinIO, right, I might have a way to
So you're thinking of some proprietary side door that you come in for imports.
Just because it feels like any driver would like to, automate it a little bit, because it knows how to create its own buckets, basically.
So actually,
objects.
Let's call it bucket imports. I like that. It's much clearer than brownfield and all that.
Yeah, but the point I wanted to make is, no matter what we do as a Cozy community, there will be proprietary side doors in drivers, right? We can't prevent that. So you have to just assume that drivers are doing the proprietary things on the side. The question is, do we as a Cozy community want to attempt to define a standard for importing buckets, or do we want to say, look, we're not touching that, that's a proprietary thing?
Right. I don't know. I mean, for now, it seems like we're okay with not taking this into Cozy, because we have enough.
Oh, I mean, we're spending all this time thinking about the brownfield use case, assuming an admin is going to do something. And I want to. I mean, this is.
But it might be the driver. The driver might have the permission of an admin. It's not really an admin, right? It's just a cluster role to create buckets, basically.
Well, I think of it differently. So with CSI, at least, the way this breaks down is there is a sidecar. Or actually, there's usually multiple controllers, right? So someone creates a bucket request. There's some controller that sees that, and in response creates a bucket. And then there's a sidecar that sees the bucket, and it goes and it interacts with some driver to make the bucket real. And then when the bucket is real, it goes and updates the bucket object with the relevant information about the actual bucket that was created. And so there's usually two controllers doing a dance in combination with the driver off on the side. So the driver shouldn't have to know anything about Kubernetes, right? It just knows about Cozy.
It's the wrong term. I didn't mean the driver in the sense of the component. I did mean though the provider's suite of software for provisioning Cozy buckets, right?
Right, but the crucial thing is the sidecar code is our code, and the driver code is some vendor's code.
No. I think what Guy is saying is you can just talk to the backend APIs, like the object storage APIs, directly and get a bucket. How does that tie into the an import a bucket? I think that's what he's trying to say. Is that right, Guy?
Yeah, I'm imagining like any one of the providers we're talking about, right? But let's take AWS for the simplicity of everyone's knowledge. But so it might be within the AWS provisioner, Cozy provisioner, right? The Cozy namespace for AWS, that you have one of the controllers there, be able to intercept some kind of event that causes it to import a bucket, right? And create a bucket for that. And then the driver does what it needs to.
That's where I was going is, is we could, as part of Cozy, invent like a bucket import request object
Right.
that would cause that sequence of events to happen that you just described, right? Like, and that could become an additional part of the API that we would have to decide, is that object namespace, is that object non-namespace, who has access to it, what do you put in it, all those questions. And then we could have a standard way of saying, okay, if you create a bucket import request, the sidecar is going to do X, Y, and Z, and it's going to call this special RPC called import bucket on the driver that'll do something. But like so far we have said no, like we're not going to do any of that. Like if you want to import a bucket, you just have to manually fill in the bucket object with all of the correct details that the driver would have put there, and the driver doesn't help you. And I'm
okay. I think we are all okay with not including that currently in Cozy, but I'm saying that providers will probably have some way of them being the generator of the bucket class and not an admin, whatever. They might have it just as a customized template somewhere, right? It doesn't really matter, but I'm saying that it might be an automated way as well.
I guess I don't know if I'm okay with that. I mean, it feels like an area for deeper exploration. We should think through, a concrete use case and the different ways to achieve it.
But what do you mean? I mean, we're saying that admins can always create a bucket, right? That's kind of, so if somebody can create a bucket, an admin gives the Cozy provisioner of AWS the permission to create buckets, then I mean, what do you mean you're not okay? You're not okay with not including a standard API, you mean, or you're not okay with providers doing that?
I mean, you're correct that an admin will be able to do it regardless of what we choose to do. And similarly, a vendor will be free to, with the appropriate level of permissions, automate the process that an admin would do.
Right.
But like, I don't know if that's.
Do you feel like it's not right?
Enough. Well, it really relegates the brownfield workflow to second class status, right? That's what it does. It basically says, as a community, we're enabling it, but only if you're willing to get your hands really dirty. And we're delegating
no,
to other
which
people
is a little bit less dirty than today. That's it. I mean, it's not that we are preventing this from further enhancing, right? We're just saying that today it's not included, but and like OBC, right? So Red Hat started with OBC, the object bucket claims, because there was nothing else. But we never said, well, if there's something standard, we won't use it. Of course we will adopt it, but that way, I guess, is the same here. You just
I didn't know about the Red Hat thing. Do they have something Cozy like in OpenShift? Okay.
Right. Yeah, it's an object bucket claim and an object bucket. That was kind of the analog of PVC-PV.
And how long ago did they come up with that?
I think it's been a while.
It's been running for 3 years almost, I think.
And we never looked at it before.
Why didn't we? We have people from Red Hat here, including you guys. Like any inspirations from that design here?
So I can tell you what happened. I mean, I've been involved like in the last 2 years at least.
Okay.
But I wasn't the one that started it in Red Hat, so I just joined that effort. But what happened was that they were trying to present it to SIG storage, but SIG storage was busy doing other things, which is fine. I mean, it was just taking time to get around this effort and get people interested enough to invest.
Yeah, this Cozy subgroup, which is operating under SIG storage, has been going at this for like more than a year at this point.
Oh, 2 years or so.
No, it's
and Red Hat was 3 years.
It was about March, wasn't it? March of last year.
No, I think before that even. I came in probably like July of last year, but before that, I believe it was running for more than a year. Even before that.
So Jeff was the common person between these two efforts mainly, and so you might consider what he did with OBC, trying to promote that through SIG storage as part of the beginning of Cozy, right? Efforts.
It's just funny because I've been here for like about 15 months, and this is the first I've heard of it. So maybe that's my fault for not being curious enough.
So maybe Jeff can tell us a story about how this all started.
Well, maybe you know the design guy, like what, like are they namespace? Are they clustered? The claims and the bucket object buckets.
So it's much more similar than what we're doing to PVC and PV. The PVC, like OBC and OB are exactly the same, but I think there was it was mostly less capable. So the brownfield case was very unevolved.
Do they have the separate access and access request objects as a extra level of indirection?
No, there is no access actually in part of it.
So
it's just
the pods
provisioning.
go straight to the buckets or something.
So the entire thing generates a config map and a secret, and then the pods are responsible to just consume that.
Right. Okay. Yeah. It was early in the course of this project that some of the Google guys were here, like Andrew Large, and he was arguing strongly for having a bucket access request and a bucket access object that would be an extra level of indirection, so that you could do credential minting and have multiple credentials per bucket, and have that all be driven through Cozy. And that was his big contribution, I think, was pushing for having that separate access from the bucket, because that makes the design a lot more complicated, but also more powerful.
It does.
So,
right. So in OBC, you couldn't do that, right?
Continue to be involved, but
right.
Haven't seen him for a while.
So in OBC, by the way, you couldn't do that, but you could do whatever so it was less standard, right? You could generate an OBC and get the driver basically, or right, the provisioner would decide what to give you, what type of credentials, but it had to give you credentials with the request, right, the claim as a response. It was like just a request for both, basically. That was the model there.
So the big power, I think, of having the separate access requests and access objects is that it makes brownfield way more practical, right? Because if you didn't have access, then the guy who owned the bucket would basically have the keys to the kingdom, and he could do whatever he wanted. But then sharing would become really, really hard because you would have multiple people trying to share access with basically the same credentials. And if you wanted to revoke someone's access, you'd have to revoke everyone's access. So having this extra access layer in the middle really helps with sharing, but then it creates this weird situation where, like, when you have a shared bucket, what do all the accesses point to, if not a bucket request? And so I'm still liking the having them point directly to the bucket. I'm not personally convinced that we can stop there and say, well, how did the bucket get there? Someone created it, right? And it's not our problem to worry about how the brownfield bucket got into the system. It feels like that's too much of a cop out, but
I mean,
it's not too bad though, as well.
Yeah.
It's not the worst thing that can happen to Cozy. I mean, Cozy can evolve to include that input.
I mean, it's reasonable. It just doesn't feel optimal.
So it's actually pretty straightforward, and like guys saying, it's not very hard to get there. I mean, just like you said, bucket import request, or why not just have a type inside bucket request that says it's an either type import or type create.
No, it's great, but a lot of questions will start. Where does this import exist? Do I create it as a user? Do I create it as a admin in the provisioner's namespace or wherever? Right? There's a lot of questions.
Everything else about the bucket request lifecycle should remain the same for the most part.
All right, well,
you're saying that the user does it, right? You're imagining that it's like a bucket request, but a bucket import request for that.
Yeah.
See.
So maybe what we should be doing then is making sure that our bucket request structure is flexible enough that we can sort of flip it around to say, I don't want a new bucket, I want an existing bucket, and make that a clear decision that you make in your BR object to say this is a new bucket versus this is an existing bucket, and here are the details.
But the problem was in the details that we were always saying that if the user provides something that only the driver can understand, then, or not the driver, but whoever, right? Somebody in the providers, the vendors, only a specific vendor can understand, right? then this is kind of becoming a bad API, I guess, or
Well,
something.
no, right?
Yes.
Because anything in the bucket request,
Like an ARN, right? ARN would be a way for me to specify an existing one, right?
Yeah, I'm agreeing with Guy here.
uh-huh.
The contents of the actual bucket object will end up being driver specific, and an end user couldn't reasonably be expected to know driver specific things. So like if I guess maybe there's a way where you could specify
Right.
something in the bucket request that was not driver specific, hand that to the driver and have the driver crunch on it and turn it into a driver specific bucket. But then the
But the
question
thing
is,
that
like,
is not driver specific, it doesn't work. I mean, if you want another layer of mapping, right, that's the buckets. And that's where you have the mapping to the external entity. But if you're already referring from the user directly to the external entity, you're basically bound, like your application is saying, this is my entity, not anything else in any other environment, right?
well, I mean, I'm thinking it's possible that you could come up with something kind of portable for this. I mean,
No, it can be an opaque string, right? A resource name or whatever, right? Something like ARN and Amazon is doing. But then if I specify it as a user, what does it mean for me?
yeah.
It means that I know my resource so specifically. Nobody can, tell me otherwise.
No, but I
Or,
don't know. Maybe there's a way to specify it in a different way, like where you're not. So for S3 protocols, there can be the bucket name is the unique way to specify it, and the provisioner is in the bucket class. So you move across provisioners, the bucket name remains the same if you're importing it.
But there's a bunch of other stuff, like there's access related information that the driver will need to do its job.
But then,
I don't
think
think
about it,
access
Sid. Think about if you have a you don't have a bucket class, right? You're just using the default, and you're specifying a bucket name, right, as an existing one. What are you saying here exactly? What do you expect?
So you do expect some driver to come and import it, right? So the bucket class has to exist because the provisioner is specified there.
No, the provisioner is specified in the bucket, right? It's something that gets copied from the.
No, you're not creating the bucket though. Aren't we talking about the scenario where the bucket is imported, as in the user just creates a bucket import request, says that, hey, this is my this is my bucket in whichever way possible, and then the provisioner goes and imports it for you and then creates a bucket object for that.
Right.
What can you use it for? Think about it. I can ask for like a well-known bucket names that every cluster should have, for example, right? Every provisioner should have. But otherwise, I'm bound to say something that only my driver can resolve to something that I mean to, right? If I tell you my bucket is called foo on AWS versus a bucket called foo on GCP, I'm not getting, the same thing at all, right? What am I specifying here? That I just want a bucket.
I see what you mean. So the problem is we're trying to model creation. So like creation itself is not like, I don't know if portability should be guaranteed at like this creation layer. Like what I mean is, if you were to say
portability of import can't be guaranteed, but portability of create should be guaranteed. Right?
But create itself is so the real problem here is these are not idempotent operations, or let me put it a different way. These are not declarative operations, as in you're not declaring that the bucket should already exist. You know, it'll only work if the bucket already exists. That's kind of the situation we're in.
For import.
For import, right,
yeah. But maybe what I've said, it's not that bad, because we're just trying to enable somebody who knows the bucket exists to be imported, right?
Oh,
That's
I
kind
see.
of,
Mhm.
it's not
So,
that we're
so
trying to make all of this request, the import request, portable to any environment, but it's like that if I do want to adapt to an environment, I can say, okay, so now I'm importing this bucket. That's my adaptation to this environment, and I get a bucket and a bucket access, and now my pods run as if they run anywhere else when I give them a bucket access request. But
yeah.
maybe the import is it doesn't have to be the portable piece. Maybe it just needs to be the adaptable piece for getting the bucket there.
But
Yeah.
it has to offer some kind of advantage over just forcing the admin to do it all, because the
Well, it's a
admin
self-service.
can do the
That's the
non-portable thing.
benefit. No, right. I think the only thing we're
Self-service,
saying
yeah.
we're getting to a self-service level of importing
Mhm.
buckets, and not just to an admin level import.
And let's say the bucket doesn't exist. Whatever you're trying to import doesn't exist. Then we just keep trying until the bucket actually exists. That's all it is.
Yeah, you would generate the sidecar would see the bucket request with the import field set up, and it would generate an event saying like the import failed because of not exist error.
Mhm.
And then the sidecar would retry like it normally does, and you would see the event would just keep recurring as long as it didn't exist.
Yeah.
The problem we have is that we don't have a good security model if we give other users this ability.
Well,
How
that's
do
where
we?
I
I
was going
mean,
to go is that in order for this scheme to actually work, like you need to be able to specify all the security information in your bucket import request that the driver is going to need to know to actually take ownership of the bucket, or get enough control of the
right.
bucket that it can create accesses. Right.
Right.
It needs to be able to create accesses and potentially also delete it.
Well,
But first
okay.
of all,
So
the driver
the
should
only
approve, right? Because
Mhm.
improving I first of all I need to
Yeah.
know if I approve the import. It's not that, because once the bucket is there, technically speaking, I am allowed to ask access. It still needs to comply with allowed namespaces or whatever the mechanism the bucket specifies. But if it does, like, anybody can now get mint credentials for that bucket, basically. And so now import becomes
Yeah.
a question of who can import something that
Right.
just,
Right.
I just named it. I just threw a name in the air. Now the driver is going to import that using its own credentials.
Yeah, that's true. That's a problem. There's
Yeah,
really no
yeah.
security to that.
But
Yeah,
this
there's no
is why I
security.
was saying we would need to go all the way through these use cases and figure out what makes sense for the brownfield case. But it feels like this is the part where we lack detail the most. Everything else
I
is feeling better.
I feel so. Yeah, our security model is kind of weird, to be honest. The only thing we have is allowed namespaces because that's what works with everything we've discussed so far. Uh, the thing I
Right,
see
because we
missing.
provide it,
Mhm.
right? We have self-service for access as well. So we have to control
Right,
that
right,
somehow.
right. I still think there should be some kind of connection between who is requesting the access, not in terms of namespaces, but in terms of the workload itself or the user. So instead of saying these are the namespaces that are allowed, maybe we should somehow tie it to a service account or a cluster role,
I
whether it's
think
the pod
I thought
itself
about
or
it later after the previous discussions. I thought about it, and I think any any separation inside the namespace, to me, doesn't make sense in the Kubernetes level, right? So the fact that I have like 3 service accounts and each one has different roles, that's great in terms of the workload. The running workload cannot do certain things. That's perfect. But if I am the user of this namespace, I can just choose whatever service account I want. So I don't have any restrictions basically inside the namespace. It's mostly that having multiple service accounts in the namespace just provides me flexibility assign different roles to the code that I run, right? And
Yeah. So
so
that's
getting
like
the
saying,
bucket access request, my point, just to complete that, is the bucket access request being able to add that to my namespace for a certain bucket. It's enough that I just know that the namespace is allowed to do that, and now it's like the user's fine-grained decision to which pods to give it to, right? That's how I see it, at least inside the namespace after the last discussions. I don't know if it makes sense to you guys as well.
Yeah.
Yeah, but
Can you
because
repeat that last?
the existence of a bucket access request gives access to everything in the namespace, regardless of how that object got created. Once it exists and is bound, everyone in the namespace can use it.
That's true also to a service account in the namespace that has permissions, like high-level permissions. Like if I have a service account in my namespace and it was given a high level of permissions, now every pod, technically speaking, can start from that service account. But I mean, the control that I get as a user is to mix and match service accounts to pods so that the code that I execute has the permissions that I meant to have. I think that's the right level that I'm getting. I'm not getting a separation that tells, and that's okay. I mean, I understand that I'm not getting the separation that inside my namespace that like I have two users inside the same namespace, right? That's not the case. It's a single user.
Yeah.
Well, why do we have different service accounts within a namespace then?
It's so that tenants can sort of further subdivide their level of access and run some workloads with lower privilege and some workloads with higher privilege within their namespace.
Yeah, you want to run one code with a different, permissions than other code, but your tenants inside the namespace are the containers images and not multiple users trying to prevent each other from accessing different things inside the same namespace. It's not
right.
It's not that level again. So to me, the level that we have right now is I think, I'm not sure, but I think it's even the ultimate one for what currently Kubernetes offers within the namespace, the control that we have in the namespace. A user has to separate to other users. It's not real.
And if a user did want to have two different service accounts with different levels of access, he could create two different BARs and use different ones for different pods, so that, let's say he had one workload that he trusted a lot, but another workload he didn't trust very much. The one that he didn't trust very much, if he decided that he wanted to cut it off, he could just revoke the BAR for it.
Exactly.
And leave the other one intact. And so it's the user's decision to sort of subdivide access within his namespace if he chooses, but
right.
Nothing is going to prevent the user from accessing something he wants to within his own namespace. It's about him preventing his own containers from accessing things he doesn't want his containers to access.
Right. You're the king of your namespace. That's where you the user is. But you can certainly control the lower level components in the namespace, which is the code, right? The images.
Yeah, I guess when I think about it, it's the same thing with role bindings as well. It's kind of at the namespace level, you're saying what can be done, what cannot be done.
Right.
It's not really that different. It's just a way in which you specify is different, but
yeah. And it's important to realize that, like, this is how Kubernetes is designed. Is namespaces are the walls between things, and users have a little bit of extra information, but not enough that we can build a security mechanism around it.
Okay, so talking about security mechanisms for bucket imports, then.
But so that's sort of outside of Kubernetes security, right? That's getting into the security of the storage system itself. Is that in order to successfully claim a bucket that exists outside the system, you need to sort of prove that you own it, right? Otherwise, someone could leverage it as an attack vector to basically guess a bucket name and say,
Yeah.
hey, this is my bucket. So any import mechanism would have to involve a scheme where you supply enough credentials to prove ownership, or you would have to be an admin, in which case the admin has access to the credentials of the cozy driver itself, and he's implicitly trusted because he's an admin.
So there's one level. First of all, there's the level of the cluster, like which cluster can claim a bucket from like the service, and that's kind of resolved by itself by the credentials that the driver has for that system, right? Basically, so it can be everything because I get like the permission to do anything, and I have an S3 admin kind of AWS permission, and then I see all the buckets in my account, and then that's this level of the cluster, and then we're asking how do I give permission per namespace that wants to do the import request in some way, right? Or is it not the question? We're talking just about the cluster one.
Well, we're saying that if you actually went ahead with this import mechanism, and if it was just allowed, it was free range allowed for anyone to just import a bucket, then even the allowed namespace that we have doesn't matter anymore, because anyone could just guess the bucket name and get full access to the bucket. So how do we prevent someone from creating?
I'm saying you would have to, so like, let's say AWS case, right? If I want to import a bucket, I would have to specify the AWS account name and password for that account, or enough secret information to log into the account, and then also the bucket name, so that the driver, without using any of its own privileged knowledge, could go in and verify that that's a real bucket and take ownership of it.
Or wait a second, but there's an alternative to that, saying that the administrator has set up the AWS provisioner or the AWS cozy provisioner, so that it has some permission, some connection to one account, right? And this account has, let's say 10 buckets, right? And then the only importer requests would the only thing the import request needs to be saying is the bucket name from the context of their provisioner, right? And not also provide like the full location information, saying which account, which region, which whatever, like all of the locator info.
But how's that not a security hole?
No, what it does is saying this, that I assign the cluster for that scope, right? The account, or even something sub account within AWS, so I can provide an IAM which has permissions to see just 3 buckets, right? And not the entire list of the account. And then I give that to my Kubernetes cluster cozy provisioner of AWS. And then inside the cluster now, the question is, what type of mechanism do we need to prevent different namespaces from specifying import? Who wants to import? What's the flow of that? Because you could also imagine that provisioner would just pre-populate all the buckets that want to be created. But then we are saying, okay, it is an interest. In some cases, we won't want to import everything. We just want to selectively import things from the account that.
But what I hear you saying is that you would like to be able to make a policy decision to have credential-less imports of buckets within a limited scope, where the scope is defined by the administrator up front.
To the driver.
Right.
Right. But still, what that means is you've made the policy decision to have credential-less imports, which means you have no security within that domain, right? Within the domain that you set for yourself, any user can jump on any bucket and take it, and nothing prevents them from doing so.
Yeah,
right?
but the domain can be
sort of drawn a fence around.
Yeah, but the domain can be as small as you want, so that might just work.
Well, right, but what I'm saying is, like, it would be better if you did have to show some token of ownership, so that you could make your domain much larger and still have some semblance of security, right?
Like CSI drivers have pod name and pod namespace on creation request. We could have something similar. So CSI drivers can get the identity of who is requesting the volume. So similar to that, maybe we can look at that too.
Oh, that was a sketchy thing done for Portworx, I think, because Portworx
I
had
see.
some Kubernetes specific logic that could only work if those additional
The
details were
identity was not.
supplied. Yeah, like CSI wasn't designed to work that. CSI was designed to be Kubernetes agnostic, right? That's the whole point. But because some people had designed CSI drivers that would only work with Kubernetes, they actually needed additional information in order to work with Kubernetes, and so that was added as like a hack.
I see.
For that specific case. I don't know. We're at the top of the hour, and I feel like this is a good discussion for maybe making brownfield more automated and more integrated. But I don't know. Is this the direction you want to be going, Sid? Where we dig deeper into brownfield and figure out a way to properly include it in the spec, and not just punt on it?
I don't mind punting on it. Currently, in terms of priorities, the highest priority is actually going through the API review. But here's my problem with just thinking of it that way, because there is something wrong with our access model. We're seeing some flaws in it, which is, I mean, at least for the brownfield case that we just talked about, and that might that might end up fixing that might end up making changes to the existing access model we have. Something about the existing access model doesn't sit right with me. I still can't point my finger
Which
at
part?
it, but just the sharing, sharing across namespaces.
The access sharing, the fact that
Yeah.
the access reference the bucket.
Well, no, if you want to access a bucket from a namespace different from the namespace in which you created it, it's kind of a weird workflow. I can't tell you what exactly is wrong. Thinking about it, technically everything seems right. Yeah, but if I don't come up with a better solution, or if I don't come up with a real reason, we'll go with what we have. But other than that, my focus is just on getting the KEP through. So in the meantime, if we figure out this, that's fine. There is one other priority that we have in terms of what we need to figure out, which is how is this going to tie into the pod lifecycle? Like what are we going to do in the kubelet eventually? But other than that, in terms of big picture stuff, I think we're mostly okay. There are some user experience things that still are on my mind, but those are minor.
And how do we get through the API review? Seems like this is a political, hard to get like people's time and.
Well, it's just that if you try to
that.
do it in the 3 to 4 weeks before a feature enhancements freeze, everyone's running around like chickens with their heads cut off. If we did it right now, most of the API guys are not looking at KEPs, they're looking at code or doing something else, and we could get their attention. But yeah, if we wait another month, we'll be back in the boat where we're staring at enhancements freeze in the face, and
right.
we're trying to scramble to make the deadline.
Yeah, the last time it was we were in a tough spot because we were reviewed on the day before the deadline, and we were actually trying for 6 weeks before the deadline. Ben, I mean, this time we'll again try early. I mean, we've addressed some of the major concerns that were there, and let's see how it goes. But before we can do that, like Ben and Guy, I'll share whatever I have with you. Once my internet is back, and let's iterate on this. We can show it to Tim right away, but I'd like you to take a look and make suggestions as well.
We can try to list the out of scope and future kind of outlook on these topics may be better, and maybe that will help them understand like if the API is complete enough, right? Something of that sort.
Well, there were problems with completeness, but the bigger problems were with simply just stuff like bucket sharing and self-service. The question kept coming back. The user can't really do self-service because there is that admin step of creating the bucket class involved. Now we have a better answer to that. That's all has changed. And same thing with bucket sharing. We've really just gone ahead and said we'll stick with the existing model. So Yeah, a major problem I think last API review was just the KEP needed a lot of improvements. The KEP was not in a good shape. That's why I took over, and I'm writing it from scratch, just cleaning up, just deleted the whole thing which was there before.
Right.
Yeah. Anyway, so our current priority is finishing the KEP, but I don't know how much help I'll need on that. I can write the whole thing, and I think that might be better for consistency's sake, at least for the first version.
Was it, Sid, are we going the direction you want to go with these design meetings and spending time on the appropriate things?
I would ideally like to change this to update meetings,
Okay.
where we just give updates on where we are. But others need to be here before we move forward in that direction.
Okay. Yeah, I have to drop off. I want to make sure that we have some semblance of an agenda and we're moving in towards a goal instead of spinning.
Right.
Okay.
Right. Yeah.
Thank you,
Thanks
guys.
yeah, thank you, Ben.
Bye-bye.
Thank you, guys. Bye.